This video is presented to you by www.testprepadda.com. Dear students, in this session, first I will tell you about inductomeric effect, and then I will discuss a very special effect, mesomeric effect. First, inductomeric effect. If I take CH3, CH2Cl, this is ethyl chloride. This is ethyl chloride. When reagent like OH minus, when this reagent approaches ethyl chloride, it approaches in this manner. This reagent approaches from backside. Now, why backside? We will discuss this in detail later on, but you can understand this by looking at the nature of OH minus and Cl minus. You can see both these are basic in nature. That is why they repel each other. And to minimize repulsion, the distance should be maximum. That is why backside attack. Okay, in ethyl chloride, Cl is attached with carbon. Cl is more electronegative than carbon, so it will pull shared electrons in this manner. When OH minus approaches this ethyl chloride, this tendency increases. This temporary increase in the inductive effect is known as inductomeric effect. Why do I say temporary? Because it comes into picture because of the reagent. Let me define this properly. Inductomeric effect is defined as the temporary increase in the inductive effect of a molecule by the approach of a reagent is known as inductomeric effect. Inductive effect, please note, inductive effect is a permanent effect. Inductive effect is a permanent effect, while this inductomeric is temporary effect. And this temporary effect comes into picture when a reagent approaches the molecule, and that is why this inductomeric effect is known as polarizability effect. While this permanent inductive effect is known as polarization effect. In 1943, Remick, he used the scripts S and D for permanent and temporary effects. S means stable and D means dynamic. So for inductive effect, he wrote IS. S for the stable means permanent, and for inductomeric effect he wrote ID. My point is clear. So this is all about inductomeric effect. Now I will talk about mesomeric effect. Dear students, mesomeric effect arises because of the phenomenon mesomerism or resonance. You must be aware of resonance. We have already discussed this resonance in one of the video lectures. Now, what is resonance? Dear students, as you know, we draw Lewis structure of any compound on the basis of properties of the compound. For example, this is the bond structure of water. Means this structure of water will explain all the properties of this compound. But for some compounds like benzene, for some compounds, it is not possible to explain all the properties of compound on the basis of single Lewis structure. So, two or more Lewis structures are drawn to explain all properties of the compound. For example, for benzene, we draw five structures, and we have discussed this in the session where we talked about the resonance. These structures are called resonating, canonical, or unperturbed structures. In 1926, Heisenberg called this phenomenon as resonance. And in 1933, Ingold called this phenomenon as mesomerism. Okay, now I will take two cases here. Consider two cases here. Case 1, if I write aniline. Case 2, if I write nitrobenzene. Now, in resonance, we have discussed that whenever lone pair is in conjugation with double bond, that molecule, that compound will exhibit the resonance. Or whenever double bond is in conjugation with double bond, double, single, double, this will also exhibit resonance. Okay, now you can write different resonating structures here. I have already told you how to write resonating structures. The breaking of bonds in this manner. So the second resonating structure will be written in this manner. Negative charge will come here. Since nitrogen is giving its electron, that is why nitrogen gets plus. Now recall the thumb rule that we discussed. There I told you, whenever you find this type of situation, lone pair negative charge, single, double. This is the first atom. This is the second atom. This is the third atom. You put your thumb here, and then with the help of your finger, you shift lone pair here and double bond here. Okay. So in this situation, this is the first atom, this is the second atom, this is the third atom. Where will you place your thumb? Here. And this lone pair will be shifted here, and double bond will shift here. So I will draw another resonating structure in this manner. Double bond here, lone pair here, one double is already here. Now for another, you will place your thumb here. This lone pair will be shifted to this carbon and double bond to this. So another resonating structure will be double bond here, lone pair will come here, and double bond NH2 plus is already here. Now back to the nitrogen lone pair. So double bond will come here and then NH2. This way you can see there are 5 resonating structures. These are the 5 canonical structures of aniline. Okay. Similarly, if I draw the resonating structures for nitrobenzene, The oxygen is more electronegative than nitrogen, shifting of electrons in this manner. So the resonating structure second will be plus will be developed here, double bond here, nitrogen, oxygen will get lone pair. And now here also same situation, plus single double. First atom, second atom, third atom. Where you will you place your thumb? Here. And plus will be shifted here, double will be shifted here. And this way I will write the resonating structure. Double bond will go there, plus will come here. One double is already here. N O O minus. Next resonating structure I can write in similar manner. And the last resonating structure here this. Again, you can see 5 resonating structures for nitrobenzene also. Okay. Out of these two cases, in case 1, the electronic displacement is away from the attached group. While in case 2, the electronic displacement is towards the attached group. Now, if I generalize these two examples, I will write this conjugated system. Here I attach group X. In the second I will attach a group Y. So what is happening in case 1? The electrons or electronic displacement is away from the attached group. While in this case electronic displacement is towards the attached group. With respect to benzene ring, if I talk about, these two positions are known as ortho positions. These two positions are known as meta positions, and this position is known as para position with respect to group X or Y. So what is happening in this first case? In the first case, again if I draw the structure, in the first case what is happening? The electron density increases here. Electron density increases here. Electron density increases here. Just check the resonating structures of aniline. While in the second case, where electrons are moving towards the attached group, the electron density decreases. You can see the resulting structures of nitrobenzene. Positive charge develops at ortho and para, means electron density is decreased. Here electron density decreases, electron density decreases, electron density decreases. Here electron density increases, electron density increases, electron density increases. And if I take aniline case, the electron density of nitrogen decreases. Electron density of nitrogen decreases while at ortho and para electron density increases. So, because of this resonance, because of this mesomerism, at one place electron density increases, at another place electron density decreases. In this case also, electron density decreases, here electron density increases. My point is clear. So, resonance or mesomerism results in a different distribution of electron density than would be the case if there were no resonance. This decrease in the electron density at one position and increase in the electron density at another position is called mesomeric effect or resonance effect. My point is clear. Now if you recall the case 1, there the electronic displacement is where? The electronic displacement is away from the attached group. This is known as plus M or plus R effect. Plus M means positive mesomeric. And in the second case, the electronic displacement is towards the attached group. Towards the attached group, this we call as minus M or minus R effect. In very similar like inductive effect, there we said plus I and minus I. Plus I was electron releasing group and minus I was electron withdrawing group. Here also plus M or plus R means electron releasing, electron pushing group, and minus M effect group means or minus R effect group means electron withdrawing group, electron withdrawing group. Dear students, different plus M effect groups are means electron releasing groups are O minus, S minus, Nr2, NHR, NH2, NHCOR, OR, OH, OCOR, SR, SH, VR, I, CL, F, R. These are different groups. What type of groups? Plus M effect groups. Plus M effect groups means electron releasing groups. Now I am writing the minus M effect groups. CHO, CO, COOR, NO2, Cl. These are the minus M effect groups, means electron withdrawing through resonance. Electron withdrawing through resonance. And students, please note that mesomeric effect or resonance effect is a permanent effect. This is a permanent effect like inductive effect. This is also permanent. Now let me tell you the comparison between inductive and mesomeric effects. Dear students, first important comparison, both inductive effect and mesomeric effect both are permanent and these effects operate in the real molecule and collectively known as polarization effect. This is important to tell because there are temporary effects also. As we have already talked about inductomeric, there is one more temporary effect, electromeric effect, and these temporary effects arise due to approach of reagent, and those temporary effects are known as what? Polarizability effect, while these two permanent effects are known as polarization effect. And as I told you earlier, in 1943, Remick gave what? S and D for the representation of permanent and temporary effect. S means stable and D means dynamic. That is why for inductomeric effect we write ID and for inductive effect we write IS. This point is clear. Now the second point. Now the second point. In inductive effect, electronic displacement is along sigma bonds, while in mesomeric effect, it is along the pi bonds. Please note this is very special difference. We have seen this. If I take the example of aniline, you can see lone pair is in conjugation with double bond. Electronic displacement is along the pi bonds, while in case of inductive effect, if I take this example, you can see the electronic displacement is along the sigma bonds, a basic difference between inductive effect and mesomeric effect. Now I will talk about the third point. Another important point. In inductive effect, there is a partial shifting of electrons, while in a mesomeric effect, complete shifting of pi electrons. Complete shifting of pi electrons. And you can see here, because of this, you can see here, lone pair of nitrogen, complete shifting, while here partial shifting, and because of this partial charges are developed here, while here full positive or negative charges are developed. And that is why in majority of cases, in most of the cases, mesomeric effect gets preference. Mesomeric effect gets preference over inductive effect. So, if these two effects contradict each other, you will prefer the effect what? Mesomeric effect. My point is clear? Now I'll take another point. Another important point. Inductive effect decreases with distance, while mesomeric effect is independent of distance. Please note, inductive effect decreases with distance and can be neglected after second or third carbon, while mesomeric effect is independent of distance. My point is clear? Dear students, till now we have talked about mesomeric effect and resonance effect in a same manner. We have said that both the effects are same. Actually, this is not true. So now I will tell you the difference between resonance effect and mesomeric effect. Dear students, most of us feel that resonance effect and mesomeric effect are completely same, which is true in majority of cases. But strongly speaking, the term resonance is not the same as mesomeric effect. In mesomerism or mesomeric effect, there is a permanent polarization. There is a permanent polarization, and the mechanism of electron transfer is permanent displacement of electrons, which occurs in a system of type like double, single, double. This is pi conjugated system, or Z single bond C double bond C. This is p pi conjugated system, where Z can be like Nr2, Z can be like Cl, etc. Okay, so essential requirement for mesomeric effect is presence of multiple bonds. Multiple bonds. the conjugation. Okay. On the other hand, the resonance effect includes all permanent. Resonance effect includes all permanent electron displacement in the molecule in the ground state. For example, if I take hydrogen chloride, hydrogen chloride in this molecule is actually a resonance hybrid of two resonating structures, this and this. Since no multiple bonds are involved here, mesomeric effect is not possible. Here, multiple bonds are not involved. So, mesomeric effect is not possible. So, what can you say? all all mesomeric effects are resonance, but all resonance effects are not mesomeric. This is the basic difference between resonance effect and mesomeric effect. Although in the majority of cases the two effects are same, that is why we consider both the effects same. My point is clear? Okay. Now in the next video lecture, I will talk about the applications of mesomeric effect or resonance effect. Okay. Thank you. This video is presented to you by www.testprepadda.com. TestPrepAdda.com provides free audio-visual lectures of different subjects by expert faculties, free online tests prepared by expert faculties to students who are preparing for engineering or medical entrance exams or planning to take exams like KVPY, Olympiad, etc. It provides a platform where students can interact with mentors to improve their performance in the exams. The mission of this online medium is to help students to achieve their goals. Log on to www.testprepadda.com to watch free video lectures on different topics, to download free revision notes, to take free chapter-wise online tests, progressive test, and mock test, to discuss doubts with mentors. Thank you for watching the video. To stay up to date with the latest videos, subscribe to our YouTube channel. Like us on our Facebook page, Test Prep Adda. All the best.